let's talk about forces. Now, you may have learnt sometime in the past that a force is a push or a pull. That's a good informal description of a force, but it's not going to be good enough for senior physics. A force is an external influence that's able to alter the state of motion of an object. It is a push or a pull, it's a vector. It's got a magnitude, but it's also got a direction, and you must remember that. It's going to be really important. We measure it in newtons. Now, a newton is actually 1 kilogram meter per second per second. Like most of the units in physics that are named after a person, the name of the person would have a capital N Newton, so the name of the unit has a small n. The abbreviation, however, is a capital N. So this is newtons, the unit of force. Some forces are what we call contact forces. You've actually got to have direct physical contact to make something move. But other forces, you probably know about magnetism, for example, it's non-contact. You can make something move without actually coming into contact with it. When there are multiple forces acting on an object, we have to calculate the net force, sometimes called the resultant force, using vector addition. It's really important. The directions matter. For example, if two people are each pushing on a box with 100 newtons of force, the net force acting is 200 newtons. The vector addition of those two in the same direction. Oh look, wrote it on for me. But what happens if we're pushing in opposite directions? Well, actually, this force and this force are going to cancel out, and there's no net force on this box. The box is not going to move. What if I do it like this? 100 newtons pushes this way, and 100 newtons pushes that way. The resultant force is going to go in that direction. But be careful, it's not 200 newtons. We have to do a vector addition. 100 newtons up and 100 newtons across, which means this is actually going to be 100 root 2, or about 140 newtons in that direction. If you want to get it exactly, that's my resultant force. Yeah, I've probably got room over here. The size of my resultant force is the square root of 100 squared plus 100 squared. I haven't got my calculator ready, just a moment. Okay, here's my calculator. The square root of 100 squared plus, oh, it's not going to do that right, brackets. 100 squared plus 100 squared. Yep, 141. Okay, 141 newtons, and the angle here must be 45 degrees because those two lengths are equal. Okay? All right. If I have more than two forces, or if they're not at right angles, it becomes a little bit more complicated, but it's the same basic process. For example, suppose I have a box and there's three forces acting. One is 100 newtons at 30 degrees. Oh, I've got to know what this means. When we first started vectors, you'll remember that you use the right-hand rule. Now, how can I show you this with my webcam? You've got the right-hand rule. You hold it up facing you, like this, and then the fingers move around the direction of positive. So it's anti-clockwise for positive angle. And the 0 is horizontally to the right. So this would be 0 degrees. Okay? So 100 newtons at 30 degrees is this way with 100 newtons. And that is 30 degrees. The second force is 200 newtons at 180, so that's the opposite direction, and it's 200 newtons. Maybe I should put the N in for newtons. And the last one is at 270 degrees, 90, 180, 270, and it's 200 newtons. And we have to work out the resultant force. So what we do is we add them as vectors. Now, if you do Maths C and you're comfortable with I's and J's, feel free to use I's and J's to work this out. I'm just going to set it out carefully as a horizontal problem and a vertical problem. Well, it's really a east problem and a north problem. You know, it's not important. This way positive, that way positive. So this way positive, the resultant force is, it's the amount of the first force that's along this angle, which is 100 cos 30. Then this one's pointing in the negative direction, so minus 200. I'm just going to adjust my screen a moment. That's better. This one, the third force, makes no contribution to the left-right movement. No contribution at all. The east-west movement, if you like. So that will be my resultant force across. I need to call that something other than R. Give me a moment. I'm going to call that one A, for want of a better word, one of a better letter. Okay, calculator. 100, can I type cos? Probably not. Cos 30 minus 200. Oh, I need to check, am I in degrees? I'm in radians, I need to fix that. It needs to be degrees. Okay. Minus 113. Negative 113. And that's actually newtons. Now it's negative, which means the net force is to the left. And I expect that because this is much bigger than that. The vertical, or the north-south, this first force contributes this part, which is 100 sine 30. 100 sine, I may as well put the degree sign in. This force makes no contribution to the north-south. This force is entirely 200 in the downwards direction. Negative, whoops, that was supposed to be a plus. Plus negative 200. Okay, calculator, move it away so we can see. 100 sine 30 minus 200. So the north-south bit is actually downwards or southwards at negative 150 newtons. Now, the last time I did this, I made a terrible mistake. I wrote 200 instead of 150, so let's try again. To work out the resultant force, I have to combine these two components. So, negative to the right means I've got a positive component to the left of 113 newtons. Minus 150 up means I have a downward component of 150 newtons. And I need to find this resultant force there. Well, the size of that force is given by Pythagoras' theorem. 113 squared plus 150 squared, which is not what I wanted. I wanted this. Okay. Square root of 113 squared. Nope, can't type like that apparently. Let's try again. 113 squared plus 150 squared. Oops, that didn't work. Squared is 187.8. Whoopsie, not doing well today. I want a pen, please. The number was 187.8. 187.8 newtons. And the angle here is inverse tan of opposite on adjacent, 150 on 113, which is make sure I'm in degrees. I am. Inverse tan of 113, no, 150 and 113. 53 degrees. 53 degrees. So if I'm going to write my answer in one go, the resultant force is 180, may as well call it 188 newtons at what angle? Well, 53 degrees is this angle, but all our other angles are described as anti-clockwise from to the right. So it's 53 plus the 180. It's this 53 plus the whole 180. And 53 plus 180 is going to be 233 degrees. Oops, we've gone off the edge. 233 degrees, that'll do.